Hey guys, today we're going to be diving into motion graphs. So in your notebook, we need to find a new page. I think we're on page around 38 of your notebook. And we are going to title this motion graphs. Now, you're going to end up having a subtitle today because for motion graphs, we focus on two different types. The first is a speed time graph, which is what we're doing today. And then later on, we'll look at distance time graphs. So motion graphs is your main title, and then we need a subtitle for today for speed time graphs. Okay, so before we look at a specific speed time graph, here's what we're going to do. We're going to draw about 6 different graphs today, and the first one, we're just going to get the basics of a graph down. So you should be familiar with graphs from math. So here's our axis. The horizontal line, this one down here, is our x-axis. And then our vertical line, this one right here, this is our y-axis. Now for everything that we're going to be doing in this unit, our x-axis, the one down here, is always going to be time. And remember that time can be measured in seconds, minutes, hours, even days, months, or years. Usually for this unit, we're looking somewhere here, seconds, minutes, maybe even hours. Okay, and then our y-axis, well, let's look up here, speed time graphs. Well, I know my x-axis is going to be time, which means my y-axis, this is going to be where we are graphing our speed. So make sure this is in your notebook. And then we're going to move on. So the goal is you should be able to just look at the pattern or the layout of a graph and be able to tell me what's happening in this graph. So here's our first one, or our first example. And these don't have to be perfectly straight, just get it on your paper. So we know the x-axis is time. We know the y-axis is speed. So here's the first pattern. We're just going to draw a horizontal line on our graph. So what does this mean? Usually, whenever we look at a straight line, we want to say, oh, well, there's no change, so it's not moving. But remember, this is a speed. So if we were to give this a number, we could say that this is 20. And then we could label it meters per second, which is super fast. So if you're going 20 meters per second at 1 second, and then you're going 20 meters per second at 2 seconds, and then still at 3 seconds, and then again at 4 seconds, what do we know about our speed? Are we stopped? No. We are at 20 meters per second consistently, which means that this is actually showing a constant speed. Remember, constant means that the speed is not changing. So we are not at rest here. We are at a constant speed. It's very important. So as time moves on, our speed does not change. This is like putting your car on cruise control, driving down the highway to make sure that you're not speeding or going too slow. You're just staying a consistent one speed. So then let's move on to the next one. We're going to draw another graph. And we're just going to get in the habit of labeling this time. And this one is speed. So then here's my next pattern. I need to make sure we know what it means. We have a diagonal line going from the origin and then to the upward right through our graph. So again, time could be seconds, minutes, whatever. As time goes on, look what's happening to our speed. We could be at 10, and then 20, and then 30, and then 40. So at 1 second, we're going 10. At 2 seconds, we're going 20. At 3 seconds, we're going 30. At 4-ish seconds, we're almost at 40. Okay, so what is happening to our speed? It's getting greater. So if our speed is increasing, we know from our prior learning that that means that our object is accelerating. Any change in motion, which means any change in speed or direction, is accelerating. So again, straight line, straight horizontal line means a constant speed. Straight upward moving line, our speed is increasing. And actually, because it's a straight line, we know it's increasing at a constant speed, and we call this accelerating. Let's put that in parentheses, a constant speed. Constant speed of acceleration. So you may want to pause your video right here to make sure that you have everything drawn correctly. You can label the numbers if it's going to help you remember, and then make sure that you have your notes written. So go ahead and pause and make sure you're caught up. Okay, I'm going to turn my paper over. You may still have room. I'm trying to write nice and big so you guys can see. So we're going to move on to the next graph. So let's draw our axis. What always goes on the x-axis? That's right, time. Speed goes on the y. So here's the next kind of graph we need to look at. So I'm starting out going really fast, and then as time goes on, my line goes down. So we need to figure out what kind of pattern is happening here. So we can have our 1, 2, 3, 4, 5. We'll say it's seconds again. Our speed we could say is meters per second. 10, 20, 30. We could be starting out at 40 meters per second. Then at 2 seconds, we're down to 30. Then at 3 seconds, we're down to 20 meters per second. At 4 seconds, we're down to almost 0. So what's happening to our speed here? We are decelerating, or what we really call negative acceleration. Because acceleration, again, is any change in motion. So slowing down is a change in motion. So like in ELA, you'll see the word decelerating, but in science, you could also see negative acceleration. So we do just need to keep in mind that if you are slowing down, it could still be called acceleration. We just need to make it specific that it's negative acceleration. So our speed here is a decreasing speed. And then remember, this is a straight line, so this means it's happening at a constant rate also. And the straight line really is what we're going to be seeing in speed. We'll see some curved lines maybe in our distance time graphs. So make sure you have all of this written. Let's move on to the next one. We've got 2 more. So, graph, time, speed. Now, these have all been really simple just with one line. You're not always going to see that. A lot of times we want to be able to compare the speed of multiple objects. So I'm going to represent the speed of one object with a straight line, and then I'm going to represent the speed of another object with a dotted line. Now notice the angle of both of these lines are different. So let's talk about what they have in common first. First, they're going from the origin and they're going in an upward direction. Well, we know from our previous notes that an upward direction tells us that that's accelerating. Both objects are going in this direction, so both objects are accelerating. Okay, so here's what they have, or what is different. This one is closer to the horizontal, so it actually has a steady increase in speed, whereas this one, do you see how it's much more vertical? It's a lot more steep. That means this has a higher acceleration. It reached a top speed much faster than this solid line did. So you can almost think about it as a roller coaster. The steeper the roller coaster, the faster it is that you're going to go. If you're on the Titan and you're at that very top drop, right after you come off of it, you're going to be at the highest speed or the highest acceleration. Whereas if you're on the mine train and it's not as high of a hill, you're not going to be going as fast. So the dashed line shows a higher acceleration. Higher or greater, well, let's use the word greater acceleration. And another reason that this would make sense to me is because the closer you get to the horizontal, this right here, if I'm at the x-axis, I'm at 0, which means my speed is 0, I'm stopped. So the closer your line is to 0, the slower the speed, whereas the higher or the steeper your line gets, the faster it is that you're accelerating or the faster your speed. You may want to pause here, ask any questions. Make sure everything's written down, because now we're going to build one big graph that shows all of these items on it. So this one may need to be a little bit bigger than your other ones, because we're going to write some notes actually on the graph. So I'm going to draw it like this. Time, always on the x-axis. Speed on the y. So here's what we're going to see. We're going to see changes in speed on this graph. So here, now what's this part showing? It's an upward direction, so this is an acceleration. Then we're going to come across and be horizontal. Remember, that does not mean you're stopped unless it's on the x-axis. Right here, we have a horizontal line. That means we've put on our cruise control. We're at a steady, constant speed. Then we're going to speed up just a little bit because we're still going upward. That's an acceleration. Then we're going to come to a stop. We are going to decelerate or have a negative acceleration. So let's make sure that we have all of this written down. So this right here is what we would call a steady acceleration. This is a steady or constant speed.
Who are you talking to?
I'm recording, hang on. Steady or constant speed. This is an acceleration. Although a little more gradual, we'll put that in parentheses because it's closer to the horizontal. And then this right here, remember our ELA people are going to call this deceleration, which is fine. But then in our physics units, you may see this as a negative acceleration.